So, if you've ever written a basic script, you know it just runs from top to bottom, line by line. And that's a great start. But the real magic, the real power, happens when your programs can start to, well, think. When they can make decisions and repeat tasks all on their own. We're about to unpack the essential Python tools that let you build exactly that kind of smart, clean logic. Here's the game plan. We're going to kick things off by making decisions with if statements. Then we'll get into automating stuff with for loops. After that, we'll see how to get even more control over those loops, package our code into reusable functions, and even touch on some advanced tricks before we wrap up with the all-important topic of writing clean, stylish code. All right, first things first, how do we teach our code to make a choice? We need a way to tell it, hey, if this particular thing is true, I want you to do this, but if it's not, I want you to do something totally different. Believe it or not, this simple idea is the bedrock of almost every intelligent program out there. I want you to picture a fork in the road. A really simple script just walks a straight path, no questions asked. But a smarter program gets to that fork, looks at a signpost, and actually decides whether to go left or right. In Python, that signpost, that decision maker, is the if statement. It all begins with that little word, if. You follow it with a condition. Basically, any question that can be answered with a simple true or false. If the answer is true, the indented block of code right underneath it gets to run. If not, Python just skips right over it. Simple as that. Okay, but what if you have more than two options? What if there are 3, 4, or 5 different paths? That's where elif comes into play. It's just short for else if. You can chain as many of these as you need, each one checking a new condition. The really important thing to remember is Python stops at the very first one that's true and runs that block. And to complete the picture, we have else. Think of it as the ultimate safety net. If the main if condition is false and all of the elif conditions are also false, the else block is your guarantee. It will run. It's the default path, the catch-all that makes sure your logic is complete. Now let's switch gears and talk about repetition. Because let's be honest, nobody wants to write the same line of code over and over again. It's boring, and it's a perfect recipe for making mistakes. We need a better way. A way to tell our program, hey, do this action for every single item in this collection. And that brings us to the wonderful for loop. Now, here's something cool about how Python does it. Unlike in some other languages, the for loop isn't just about counting from 1 to 10. Nope. It's built to go through any sequence of items, a list of words, the letters in a string, whatever you've got. For each pass, it grabs the next item, assigns it to a variable, and runs your code. That's all great if you already have a list. But what if you just want to do something, say, 5 times? You could make a list with the numbers 0 through 4, but that feels a little clunky. Turns out, Python has a much more elegant and efficient tool for exactly this job. And that tool is the range function. You just give it a number, and it generates a sequence of numbers for your loop to use. So range 5 will give you the numbers 0, 1, 2, 3, and 4. It's the go-to standard way to run a loop a specific number of times in Python. So what's really happening under the hood here? Well, it all comes down to saving memory. See, range is what we call an iterable. It doesn't actually create a full list of 5 numbers in memory. Instead, it generates them on demand, one by one, right when the loop asks for the next one. This is super efficient, especially if you were to do something crazy like range of 1 million. Okay, so we know how to repeat actions. But sometimes just letting a loop run from start to finish isn't quite enough. We need more control. We need an emergency stop button to get out early, or maybe a skip button to jump right to the next item. And Python gives us exactly those tools. First, you have break. That's your emergency break. It slams the brakes on and exits the loop immediately. Then you have continue. That's the skip button. It stops the current round and jumps straight to the top of the loop for the next item. And then there's the loop else clause, which is a bit weird but incredibly powerful. Okay, here's the secret to the loop else. It has nothing to do with an if statement. This else belongs to the for loop itself, and it only runs if the loop finishes completely from beginning to end without ever hitting a break. This is perfect for searching for something. If you find your item, you break out. But if the loop finishes and you never found it, the else block runs, letting you handle the not found case. This feature is so unique that even the official Python tutorial has to point it out and say, hey, look closely.
It catches a lot of people by surprise because we're so used to seeing else paired with if. But once you get your head around it, it is such a clean and elegant way to write search logic.
So, as our programs get bigger, just having if statements and for loops isn't quite enough. Our code can start to get, well, messy and repetitive. The next major leap in controlling your code's flow is to start organizing it into neat, reusable blocks. And we do that with functions. A function is basically a reusable blueprint for a specific job. You define it one time using the def keyword, you give it a name, and then you can call that name whenever and wherever you need that job done. This is absolutely fundamental to writing clean, organized, and maintainable programs. Let's just quickly look at how it's built. You start with def, which signals you're defining a function. That's followed by the name you want to give it, and then in parentheses, you list any parameters or inputs it needs, in this case, a number n. Everything indented underneath that is the body of the function, the code that actually runs when you call it. But here's where functions become true power tools, when they give something back. Using the return statement lets a function send a result back to the code that called it. So instead of just printing a series to the screen, this fib2 function actually builds a list and returns it. That means we can capture that list in a variable and keep working with it.
Now, beyond those basics, Python gives us some really cool ways to make our functions even more flexible and powerful.
Here's just a quick taste of 3 of them. You can give arguments default values, which makes them optional when you call the function. You can also use keyword arguments, where you call them by name, which can make your code way more readable. And for the ultimate in flexibility, there's even special syntax that lets you build functions that can accept any number of arguments you throw at them. We've covered a lot of the technical tools, but there's one last crucial piece of the puzzle: making sure other people can actually understand what you've written. There's a famous saying in programming, code is read far more often than it's written, and it's absolutely true. Now, these aren't just nitpicky rules, they're community conventions that make all Python code look and feel consistent. When you use proper indentation, keep your lines at a reasonable length, and use whitespace effectively, the logical flow of your program, all those ifs, fors, and defs we just talked about, becomes crystal clear at a glance. It's really about communicating your ideas to other developers. So there you have it. We've gone from simple top-to-bottom scripts to programs that can decide, repeat, and organize themselves into clean, reusable blocks. You now have the fundamental tools to truly control the flow of your programs. The only real question left is, what are you going to build?